The next thing we're going to talk about here is the idea of the complement of a set. And to do that, really what we need to do is set our expectations a bit more for what the universal set is, or what a universal is. So let's drop back and talk about that example I had in mind in 2.1, the idea of a full backpack. If you're going to school, stuff in your backpack is pretty important to you for that day. So let's say that all the things in your bag are what makes up the universal set for that day, because a lot of stuff you care about is going to be in there. Let's say you're very focused on school and everything in there is the center of your universe for the hours when you're on campus. So when you reach in there and you grab stuff out, you're taking a subset. You're taking some of the items out of that bag. You're not going to be able to grab everything unless you have a very empty bag or very large hands. So you're going to get only some of the items, maybe a notebook, your laptop, and a calculator. And then there's a whole bunch of stuff that's not in there. So it makes sense that you could describe all of the things that are not in your hand in terms of the things that are in your hand, because you put the two of them together and you get everything again. That's what the idea is behind a complement. So set A in universal set U, the complement of A is a set of things in U that is not in A. Or if you wanted to look at that in terms of set builder notation, where we denote this A prime. A prime is equal to the set X such that X is in U and X is not in A. So X is this, so in this case, all those X values are stuff that aren't there. If you think about this as a Venn diagram, it's the set of things around the circle. And it's important to remember that when we're talking about this, the idea of universal set is very important because a complement can only be defined in terms of the universe that the main set belongs to. So let's take a look at a couple of very quick examples. Let's first take a shot at the one from last time where we had the graph and now popping up right there. And let's find for that graph the complement of B. Let's find the complement. So to do that, what we look at is go into that graph and see that everything in B is the regions 1 and 2. So that means it is D and E. Well, if B is D and E, that means the complement is stuck being everything except for E and E. So B complement would just end up being A, B, C, F, and G. Everything else that's in U, which would include a good chunk of A and then a couple of elements that are just hanging around on the outside. Let's look at one more quick example. So here we have the set U, the universal set, is the even numbers between 2 and 10, so 2, 4, 6, 8, 10, and A is 2, 4, 6. So for this, you want to find a complement. Well, all we do is say, okay, A is 2, 4, 6, which means the stuff that is in U but not A is just 8 and 10. So a complement is just the set 8 and 10. So for this type of question, the idea of finding a complement is really very easy, but we'll see that there's more to it when we're getting into more complex relationships as we start seeing the other operations that we can start to apply.